Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our study guide for data displays. First off, it might be a good idea to read this section and hear about stem and leaf plots, because the first few problems are going to have to do with us making stem and leaf plots from numerical data. So the stem and leaf plot is a way to display the data that shows the individual values from a set of data and how the values are distributed. So this is a situation where, some data displays, you don't see the individual data items. You just see the spread, or you see like bin widths of them. In this case, you actually get to see in this data display every single number, the minimum, the maximum, and all in between. So you've got two different parts. You've got the stem, which is, what is that? It just represents all the digits except for the last digit in the number. And leaves is the last digit in the number. Now, one thing that they're not putting in here is really important is to have a key. So I'm going to add that right now. Every one of your stem and leaf plots should have a key that tells you what these numbers represent, because you don't know if this is a 200 and that's supposed to be the tens place, or if that's supposed to be the tens place and that's the hundreds place. You don't really know unless you see the key. So if I put this in here, it says 2, line 9. The 2 is the number in the stem, the 9 is the number in the leaf. If we say that that is equal to 29, then you know that these numbers are all in the tens place and all the leaves are the numbers in the ones place. Same idea here. You've got these numbers technically represent the number of tens. So 37 in the stem and a 5 in the leaf, the 5 is going to be the number in the ones place. So if we said 37 line 5 for this key, that would mean this is the number 375. So if you create a stem and leaf but you don't put the key in, then someone else reading your data display may not really know what those numbers represent. Now, if you can see the raw data before it's been put into the stem and leaf plot, okay, well, then it doesn't matter as much. So I think that's what they were doing here, is you could see the raw data so you didn't need the key. So what you needed to do is make a stem and leaf plot for each one of these sets of data. So starting with the first set, those are all two-digit numbers. So the numbers in the stems are all in the tens place, and these numbers are in the ones place, and they're in order from least to greatest now. 18, 26, 28, 29. Oh, no, yes, they are. 30, 33, 34, and 34. So take a look here. It's pretty basic, pretty straightforward. You'll notice that 1 and 2, those are all two-digit numbers. For problem number 3, you've got some two-digit numbers and three-digit numbers. So once again, our stems are the number of tens in any given number. In the 11, that would be 11 tens. This would be 12 tens, so that's 120 plus 3 is 123 for that number. All right, so those are stem and leaf plots. Now let's move to histograms, and this is really just interpreting the histogram. Mr. Diaz surveyed his employees about the time it takes for them to get to work. The results are shown here. So it looks like the bin widths are 20 minutes. So how many people went between 0 and, I guess that's technically 0 and 19? Because remember, with these bins, this number here that ends the first bin begins the second one. So anyone who took 20 minutes to get to work would go into this bin. Anyone that took 40 minutes to get to work would go in this bin, and so on and so forth. So how many employees completed the survey? Well, we better count these up. Here you've got 6, you've got 8, you've got 5, nobody there, 4 and 1, so we'll add all those up. 14, 18, 19, and 5 is 24. So 24 people conducted the survey. How many people got to work in less than 20 minutes? Well, that would be this bin. That would be 6. How many got to work in less than 40 minutes? That would be a combined of these two bins, which would be 14. And how many people take 60 minutes? Well, remember, this number right there, the 60, has to go into this bin. Everything in here is between 40 and 59. So the 60th person would go in here if they existed. Or not the 60th person. The person who took 60 minutes would go in here. And since there's nothing in there, we have to say that is a 0. And now for box plots. And these, holy moly, they wanted to create a stem and leaf plot and a box plot for each one of these situations. So it would be nice if they would just let us do box plots using the same data from problems 1 through 4, but they didn't. So once again, we're going to go through and create the stem and leaf plots with the keys, and then we have to go through the process of finding the minimum, maximum, the median, and the 2 quartiles. So I'm going to go ahead and do that for the first 2 problems. And if you need me to work out how we got all these numbers for the last 2, I'd be happy to do it for you. Just ask me and I will do that. But I think you should by now have a pretty decent understanding of how to create these box plots. In fact, let me do, now I'll do 11 and 12. Okay, so first off, we know that the minimum and the maximum, those are pretty easy to find. So the minimum has to be 32, and that's the number right here. Actually, let me change this color. Let me change it to green. So that would be 32 would be right around there on the number line, so we would plot that right here. 35, or 85, I should say, goes right around here on the number line, so we're going to plot that right there, and that's going to be the maximum. I'll put the max right there. And my OCD is taking over, so hold on for a second. Boom, boom, yay, we have color coordination. All right, now for the median. To find the median, you've got to find the number that's exactly in the middle. So we should count them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers total. So if I start working from the ends until I eventually get to the number in the middle, looks like the number in the middle is 52. So 52, oh no, oh no, no, no. I've made a mistake. That's not where 52 goes. 52 goes right here. So it should be right there. Okay. Let me pause for just a brief moment, and I will fix that. All righty. That looks much better. So the 52 should go here because it's got to line up with your number line. And I don't know why I put that over there. Maybe I went 2 away from 60 instead of 2 away from 50 and put it in the place of 58. Simple mistake. Right, so now that we've got that taken care of, now let's find our quartiles. 52 is our median. So the lower quartile is going to be the number that is the median of the lower half. And since you've got 2 numbers in here for the median, the 45 and the 46, we'll find the halfway point between them, and that's going to give you the first quartile is going to be 45.5. We'll do the same thing for the upper quartile, find the halfway point. So you got 4 numbers above the median, so the one in the halfway is between 80 and 83, and so the halfway point between 80 and 83 is 81.5. Now remember, if you don't recognize the halfway point, then just add those numbers together and then divide by 2. You get 163 divided by 2. Use your calculator, you'll get 81.5. So, first quartile was at 45.5, and the third quartile was at 81.5, and so those get plotted. Here's your 81.5 approximately, and here is your 45.5 approximately. So you got these 1, 2, 3, 4, 5 points. Go ahead and either above or below your number line, and then box in the interquartile range, which is your quartile 1 to quartile 3, mark where your median is, and then label all of those points. All right, actually now let's do, I'm going to do number 13 instead. So problem number 13, let's make sure we got that right. The minimum is 49. That should be where 49 goes. Very good. The maximum is 83. There's approximately where 83 is on the number line, so that would go here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers once again. So I'm going to go ahead and keep working from the outer to the inner until eventually I get to a number that's in the middle, which is 68. So 68 would go right around here. That is our median. Now for the first quartile, we're going to take all the numbers in the lower half Everything below 68. How many numbers are there below 68? 1, 2, 3, 4, 5, 6, 7. Very good. We're going to have a single number in the middle there. So let's go ahead and do that whole median thing again. Looks like it's 58. So that goes right here. And on the upper part, 1, 2, 3, I bet it's going to be that number right there. So 3 from the lower region, 3 from the top. So yeah, 73 is the upper quartile. So once again, plot the maximum and the minimum, find where the quartiles are, box in the inner quartile range, and then connect everything with a line, and you've got your box and whisker plot. All right, I think that does it for our study guide for data displays. Let's go ahead and move on to the next activity. Take care. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling blessed,